Good afternoon, everybody, and welcome to our next installment of our Facebook Live Franklin Outside videos. Today, I'm joined by my wonderful TFI colleague, Director of Digital Editorial, Joy Montefusco. Joy, if you want to wave to say hello.
Hello, thanks for having me, Rachel.
Thank you for coming on, and I've been so excited to sort of explore this working from home, this new environment, because I'm learning all of these skill sets about my colleagues that I didn't know existed. For example, we learned that you have practiced as a professional landscape designer, and of course you've got a pretty green thumb over there. You're a self-proclaimed garden geek, I hear. Is this all true?
I'm a plant nut, yeah.
A plant nut, I love it. Great. So what I have been learning about myself is, even though I like going out backpacking and camping, I'm in the woods half the time, I'm actually really cruddy at tree identification. So I've brought Joy along with me today to help out, give us some tricks of the trade to understand how we can go about identifying trees and help us understand a little bit about forest composition, as it is unique here in Southeast Pennsylvania and in Philadelphia. Okie dokie.
So where are you at?
I am actually in East Fairmount Park, and this is a pretty cool area of the city. I've broadcast from here a number of times. You've seen me squashing spotted lanternflies here before, and indeed they are all around, which is quite unfortunate, and they're affecting the topic of today's discussion. Of course, these beautiful trees around me. And what you'll notice is that the forest actually, as we start to walk around, isn't as diverse as I expected it to be, even though there are far more trees in the city of Philadelphia, tree species, than I expected. There are a small handful that dominate that number of species, and we'll be talking about 4 of those today. So I'm standing in front of one right here. Joy, do you know off the top of your head what this guy is?
That's a London plane tree.
A London plane tree, and it's fairly common in our region, isn't it?
It is fairly common. It's not native, but it is a type of sycamore. And we have a native sycamore tree, which a lot of times you'll see, if you see a line of white, glowing, tall trees, pardon me, there goes a bus. It's real. If you see a line of tall white trees in the distance when you're driving in the country, that's usually the native sycamore, which has a whiter bark. And the London plane tree, which is usually planted for a variety of reasons as an alternative to the sycamore, has more of a greenish gray mottled bark, and it definitely has sort of a camo look.
Right, and that's absolutely the coloration that we're looking at here, and I find this coloration absolutely so intriguing. And I learned recently, and correct me if I'm incorrect here, that the actual outer bark layer is quite brittle, and the reason it mottles off this way is because it can't keep up with its growth rate. Is that right?
Yeah, they grow so fast. In fact, they're often planted as street trees, and when you're walking around your neighborhood, a lot of times you'll see they've been planted in between the sidewalk and the street in areas where they kind of take over and they start to look like elephant feet. They grow much faster than people expect, which makes them a little bit more of a brittle tree. They tend to lose branches in windstorms and stuff. But yeah, that elephant foot look, kind of oozing over the sidewalk, is something you'll see a lot in the city.
Kind of characteristic. Yeah, I've noticed it as well. And I also learned that London plane trees actually were proliferated on purpose here in the city of Philadelphia because they deal quite well with air pollution, and they are so named for London because it was discovered in London that about 400 years ago or so, as air pollution was getting quite bad, folks could plant these guys, and they were quite tolerant to it. Isn't that fascinating?
That is so cool. I didn't know that.
Yeah, so we'll talk about air pollution. And I don't want to get ahead of myself here, as I usually do. I get to kibitzen, but I mentioned, I'm losing some of my leaf samples here. I mentioned here that we'll be talking about 4 very common species. So you just heard Joy and I talk a bit there about the London plane tree. We'll also be talking about the Norway maple, which is another very common, perhaps invasive species here in Southeast PA. We'll also be looking at a black cherry, but kind of a unique black cherry. It's very unique from those that we see in a lot of the more finely tailored parks, or the trees that would be producing the fruits that we see in the grocery store. And finally, we'll look at an ash tree. So these 4 trees, as I mentioned, are very common in the city of Philadelphia. And we're going to start talking about some of the basics that you can pick up, some tricks of the trade to help identify these trees. Whether or not you're familiar with them beforehand or not, doesn't quite matter as long as you have a few tools in your mind. So Joy, indulge me for a moment here while I just list out some of my favorite tools. So I've mentioned before on my program that the very first tool I like to take with me every time I'm out hiking is a field guide. So my favorite that I've shown you here is from the Morris Arboretum, and it's called the Philadelphia trees. These are all about street trees, but also, of course, in public parks like the one I'm in today. And these are fantastic. They're available through your local arboretums. Doesn't necessarily have to be Morris. And a field guide is really, really handy if you get it locally, because it will speak about those trees, of course, that are local to your region. So the first step you want to have available to yourself for tree identification is probably a field guide to help you out with that immense bucket of knowledge. A second tool, and I believe we're going to provide this link in our comments section, is something called a dichotomous key. Now, a dichotomous key is a very common tool that we'll use in, let's say, botany or in the environmental sciences that help us understand if a leaf is of a particular category or not. And that's where that term dichotomous comes from. It means one of two. Right? So we're going to talk about how that can be useful here in distinguishing between two very, very similar looking leaves. And then the third item, and for those of us that have been kind of tech savvy, increasingly so over the last few months, you might be more interested in this, using a digital app on your cell phone. And I've mentioned iNaturalist before on this Franklin Outside series before. It's a wonderful technical tool to help you with any kind of outdoor species identification. It goes for trees, it goes for bugs, any kind of wildlife. It is a little bit technical though, so if you're looking for something a little bit more family friendly, check out a new app I just learned about called Leaf Snap. All one word, Leaf Snap. It was developed by researchers at Columbia University, University of Maryland, and Smithsonian. So you know it's quite accessible, quite easy to use, something a little bit more family friendly. Okay, so that's my rabbit hole down on tools.
I love iNaturalist because sometimes there are things that are really hard to identify, and it also will identify birds, insects, and other sort of living species like mushrooms and fungi. Yes. But people will come in after you and validate your identification so that you know that you're right, which is a nice, if you're a plant geek like me, kind of want to know, like, was I right? Sometimes it's really hard to tell.
It is hard to tell. And the other great feature about iNaturalist, and I'm glad that you brought that up, Joy, is that you have access to a whole network of amateur through professional level botanists, any kind of plant scientists, animal scientists as well. As Joy says, they come back and they double check your work. And you can also compare the species that you're looking at other species that are in the area. So this is quite common with trees. If we see one tree, we probably see others like it in the immediate vicinity. Okie dokie. So let's start then, Joy. I think it's probably a good place to start with understanding why it's important anyway to go out in the forest and be able to identify trees. Like as a landscape designer and someone that's really, really familiar with biodiversity and the outdoors, why do you think that is for you?
Well, there's a couple reasons. First of all, because it's cool, and our brains have room for lots of cool information. And so just knowing what you're looking at is really interesting and fun. But I think the main reason it's important is that trees are a really good indicator of what's going on in an environment, whether it's yes. a wild environment or a built environment or something that crosses over. By built environment, I mean like a city or a suburb. And I think they're good indicators of the health of the environment in that region, and what kinds of things may be affecting the environment in that region. And I know you look at it from a climate perspective as well. Like what yes. do the species of trees that you see in an area tell you about the climate?
Yes. Yeah, and in fact, that's exactly what I'm trained in. I'm trained in paleo climate, right? And we've talked about this as well on this program before. That means the study of climates in the past. And trees and fossil trees and leaf imprints can tell us a whole heck of a lot about paleo climate conditions. But I'd like to come back around to that and jump right in here to, oh, you know, I could chat about this all afternoon. Okay. So I'd like to come back around though and start with some of those basics of leaf identification, because I think for those of us that are just starting out here, including myself, the intrepid researcher, it's kind of tricky to start distinguishing between all of the different tree species that we come across. But leaves, of course, certainly in the summertime, can be a really, really powerful tool to help us understand what kind of tree species we're looking at. So let's start then with some of the basic factors there, Joy. How about we start talking about leaf shape? What are some of the different leaf shapes we might come across?
Right, so lobed versus unlobed. or rounded would be a question. The first question you might ask, what's the shape? Do you see actual lobes are sort of growths that come out of a central kind of place? So what's a less technical way to say lobe?
I have one here, so glad you should ask. We have a lobed leaf here, and go ahead, Joy, I'll let you continue your description there.
Right, so you can see this is a, well, I won't say yet what it is, but it is a common tree, and it has typically about 5 lobes. Sometimes there are little extra little bits like down at the bottom there that aren't fully complete lobes, but that's its classic shape.
Sure. Yeah, I agree. This is quite a common tree. I actually already mentioned the tree name. For those of us that were paying attention, go ahead and guess in the comments section if you know off the top of your head. We'll reveal it in just a moment. But as Joy mentioned, the lobe shape has to do with the outermost edge of my leaf. So we're looking at 1, 2, 3, 4, 5 main lobes, and this is distinct from another type of morphology. Here's another leaf that looks quite similar, but actually is quite different. And when it comes to lobes, you can see that this only has 3. So 1, 2, 3. So on these.
Oh, sorry, go ahead. I was going to say one way that you can tell how many lobes, sometimes it can be hard because not all leaves are perfectly shaped exactly the same, but you can see the veins that come out from the center stem of the leaf.
Yes.
And count those, and those should each lead to a lobe.
Joy brings up another excellent point, and I'm going to get the leaf really close here to the camera so you can see those main veins in there. So of course, the veins help move nutrients and water through our leaf, and here we have those 5 main lobes, and you can see very distinctly, actually quite well in this camera view, 1, 2, 3, 4, 5. And what I find fascinating, the more I learn about leaves and their very diverse morphology, is that even venation, or the pattern of those veins, can differ wildly, even sometimes within the same category of species, which is really fascinating to me. So I'm endlessly interested, actually, in what we're looking at here. Okay, so we've talked about leaf shape then. How about we move to the edge of the leaf, because these actually both have kind of spiky looking edges, don't they, Joy?
Yes, they do. They are they're serrated, or they have little teeth on the edges. So like a bread knife, they've got little teeth, little jagged edges, and sometimes the serrations are very fine. Some small leaves, you really have to look closely, but then you can see that they don't have smooth edges; they have serrated edges.
Yes.
So that's another thing to check for right away.
Excellent. So we're looking at lobes, and we're helped along there by the number of veins inside. We're looking at, so that was the overall shape of the leaf. We're also looking at the edges of the leaf. We're showing 2 here that, as Joy mentioned, they kind of look like they have teeth, don't they? They're jagged along the edges here. And in just a moment, we're going to switch locations, camera locations, to look at a leaf that has a little bit more smoothly edged leaves as well. And then we've got another category here that has to do with compound or simple, and I'm going to actually ask you, Joy, to put that on the back burner. So okay. I'd like to show that at our next tree. So we're going to go for a little walk here. We have a guess for what kind of tree this is. I believe I asked this one here. Go ahead. Somebody asked if this is a sycamore leaf. Well, I can tell you that one of these 2 leaves is a sycamore leaf, but I won't tell you which. Oh, I have too much fun. Okay, Joy, we're going to be on the move here.
Excellent.
And as I'm walking here, maybe you could tell us, we're about to get into talking about both the arrangement of the leaves, but also thinking about simple versus compound. So what are those words that I just used there, simple versus compound?
Right, so a simple leaf is oftentimes not simple in appearance at all. It may be very complex, like the leaves that you're holding, but all that means is that there's one leaf that's growing from each stem, or that's attached to the tree branch. Compound means that there are many leaflets that are attached to the stem. The petiole is a piece that's attaching the leaf to the tree. And so it may look like many leaves coming out of a branch, but it's actually not a branch, it's a leaf, sort of the leaf center stem.
Okay. Excellent. So you mentioned there, you used that word petiole, and this is actually one of my favorite leaf anatomy terms. And it actually is the structure that's holding the leaf to the stem. So I'm going to get really close on this. And Joy, can you tell us what exactly, I'll give it away. I told you we were going to come and look at a cherry tree. I think you can see that structure. Can you see that structure okay?
Yeah.
Or maybe now, how about we bring that the white paper there? Yeah, that'll be great. We can put some white behind this and make it a little bit easier to see. There we go. Thank you very much to my director. I have some help here on the trail. Lovely, lovely.
Oh, that's great.
Much better. Okay, Joy, tell us what we're looking at.
So what you're looking at is you're looking at a simple leaf, meaning that all the leaves are attached to a branch of the tree at the base, at the petiole.
Right. So now that's an excellent point. Can you hold my camera, please? And I'm going to point out what Joy is talking about. Thank you. Right there will do. And that petiole, as Joy mentioned, described to us there, is that stalk that's holding the leaf on to our branch here. Now, these are simple, as Joy mentioned. If we had multiple leaves coming out of the same branch, of course, we'd be talking about compound. But there's another feature about these leaves, Joy, that I wanted to point out, and it has to do with their arrangement along the sides of this branch. So I'm noticing that these are actually, it looks like there's a leaf and then an inch and then another leaf and then an inch and then another leaf, right? And that has to do with, now, is this an opposite? Is this, what are we looking at when we're talking about leaf arrangement?
We're calling this an alternate arrangement. And so, yeah, that just means that the leaves are staggered sort of every other, rather than two or more leaves coming out of the same place on the branch.
Okay.
One leaf, and then on the other side of the branch, another leaf. And then on the other same side of the branch as the first one, the next leaf, and so on. Okay.
It's kind of like back and forth, back and forth. Okay.
Yeah.
And while we're here, I'll switch to another example that shows us that a paired style of arrangement. But while we're here, I want to point out yet another type of leaf edge. And here, Joy used the term, it almost looks like a bread knife, doesn't it? I think that's actually a really perfect term for what we're looking at here. This is yet another variation of leaf edge, and it has really, really prominent teeth. I think they look like little sharp edges there. And those are all additional clues to help us understand what type of tree that we're looking at based on its leaf. All right, we're going to go on one more little field trip here. I'm going to take you with me. And as mentioned, we're going to go look at leaves that are in a different arrangement. So Joy just wonderfully described for us what an alternate leaf arrangement looks like. And here we have another type of arrangement called an opposite arrangement. So I'm going to ask my director again to hold that camera, and we'll come down here. And here we go. And we'll put that camera just a little bit down.
And you've got what looks to be a sprouting ash tree.
A sprouting ash tree. Joy knew that right off the top of our heads here. Fantastic, Joy. So tell us what gave it away as an ash tree for you.
Well, I can see that it's a compound leaf. It's a little bit hard to tell in the picture, but that means that there are many leaflets that are coming out of the central stem of the leaf before it attaches to the branch of the tree. I can see that the leaves are in pairs so that they each attach to the branch at the same place. And that's actually a nice clue that you can use to identify trees even when they don't have leaves, because when leaves fall off, the petiole leaves a small little scar on the twig of the tree, and you can tell whether they're paired or whether they're alternating.
Okay, so what you just mentioned there then is we have an advantage here because we're doing tree identification, of course, in the summertime, right? And so all of the trees we've been looking at are called deciduous trees. And that's probably a term you've come across before. This is in comparison to, for example, evergreen trees. So deciduous trees are these broadleaf trees that drop their leaves in the fall, and then they grow back in the spring. And as you were talking there, Joy, I had another question. If I were to come back in the spring, this ash lost its leaves, would it grow leaves again from the same exact area where the previous year's petiole attached to the stem?
I don't believe so, but I'm not 100% sure.
Okay, well, we'll have to do some homework around that.
Yeah.
But as Joy mentioned there, a great identification technique then in the wintertime is to look at that pattern of scarring. So is it following that alternating pattern, or is it following that paired pattern? Okay, so let's recap there. We just went through a whole bunch of ways to identify a tree based only on its leaves. So we talked about its overall shape. Remember, we looked at potentially 2 different leaves. Here I've got those on hand again. And we saw that these had different lobes. One of these had 3 lobes and one of these had 5 lobes. So Joy, I'll let you tell us on my 5-lobe leaf here, which tree were we talking about for this guy here?
That's a Norway maple. And it is nice. Actually, it's a great tree to learn. You don't have to learn that it's a Norway maple necessarily, but it's a great tree to learn kind of the overall look of a maple leaf. There are many, many, many kinds of maple leaves around, maple trees around, and it's an easy one to identify. It's on the Canadian flag. It's on your, if you use maple syrup, it's usually on the front of the bottle.
Yes. Fantastic. So Joy hit the nail on the head. We're looking at a Norway maple here. Of course, she's quite practiced in leaf identification here. And I'll throw another little bit tougher one at you. This leaf had only 3 lobes, remember? And it's kind of similar looking, but a little bit different. Can you tell the difference between those 2?
Yes, I can.
And now what are we looking at here?
We're looking at the London plane tree leaf.
The London plane tree leaf, right? So we started off chatting about the London plane tree. These are quite common in Philadelphia.
And in fact, we have a whole line of London plane trees growing down the parkway in front of the Benjamin Franklin Parkway in front of the Franklin Institute. In front of the Franklin Institute,
that's right. So when you get a beautiful day, come on down and take that walk. It is quite gorgeous. And it sounds like we have a question.
Why are they called lobes?
Why are they called lobes? It's a wonderful question. Joy, do you want to jump in and tell us why the leaf shapes are called lobes?
No, I don't think I can tell you that. I'm sorry to say. Why are they called lobes?
That's quite all right. I would imagine that's actually just a scientific adaptation of a common parlance. A lobe is something, of course, in structure, in morphological language. We use this in geology all the time to refer to rock features and mountainous features as well, to refer to an outgrowth almost of an overall structure. So if you imagine the leaf mass here in the middle, the outgrowth structure is kind of that larger structure that pushes outwards. So I'm going to go ahead and exactly our earlobe as well. So that's a great application of how sometimes common terms can be adapted into scientific terms. And we had a second question.
Can you get syrup from all maples?
Can you get syrup from all maples? Joy, do you know if we can get syrup from all maples, including the Norway maple here?
Technically speaking, you can get something from most maples by tapping their syrup. However, it's the sugar maple that we get our maple syrup from, and that's because it has a very strong sap flow in the spring, and it produces a lot of sap. Now, other maples don't produce that much sap, and it also has to do with the environment. Sugar maples produce best in an environment when there's a cold winter. And so here in Philadelphia and the surrounding area, we don't have super cold winters most of the time. And
mild.
So we don't, but you can technically, most trees will give you a little bit of sap, but the fact is you have to boil that sap down and concentrate it so much to make maple syrup that it's not really worth your effort unless you can get like gallons of sap from each tree.
Right, so not economically viable, but perhaps if you're interested, you could try in your backyard. I think you're right there, Joy. I think it does make quite a dilute syrup. So unless you're interested in watery pancakes, I don't know that we'd recommend the Norway maple for your syrup making desires. Okay, great. So I think we've hit then on all of the categories of leaf identification that we can really go into. Oh yes, of course. So we talked, about the number of lobes. We also talked about the edges of those lobes. And here we saw some of those, here we are there, some of those teeth. And we saw in the cherry leaf, of course, much smaller teeth. And here, if we get up close, if you can pull the camera close again, these almost look like they have rounded teeth. And I'll go ahead and I'll put my board below them again. And those look quite smooth. Joy, can you see those well?
Yes.
Yes, and sounds like this is a fairly common feature then on ash trees.
Yes.
Okay, great. So we looked at those edges, and of course we also looked at whether or not the leaves are simple or compound. Alrighty, so those are the major categories then to identify trees based on their leaves, but there's all kinds of other variation that any given tree species can show us, of course. Joy, what else might we look at if we don't have the leaves available to us to help identify our tree species?
Well, when I took tree identification courses, we actually had to identify trees based on twigs in the winter with no leaves. So you can use the twigs. There are lots of things that you can look for example, where the leaf scars are, what kind of bark you have. Twigs often don't have the same bark characteristics as the full-grown tree. They'll have a smoother bark, and they may not have the shifts in coloration, but bark is a great one. So
Right. So I've got some bark behind me. Yeah, go ahead.
Yeah, so what do you notice about that bark? What does it look like to you in the pattern?
So I hope you can see it as well. It's quite a light color, obviously. Oh, and look, we have a little spotted lanternfly nymph, and I'm gonna crush it, and I'm not gonna show. There it goes. We got that. Okay. always on the ready here. So the Norway Maple. I'm kind of noticing that it's excuse me, I'm sorry, this is the ash tree, of course. This is quite smooth to the touch. It's kind of a lighter grayish color. And it almost looks like those ridges in there, they almost look like a lace pattern. Are there other features that I should be picking up on an ash tree to help me identify it?
Sometimes you'll see on certain trees, there's green ash and black ash and white ash, but sometimes you'll see what looks like a diamond shape pattern in the bark. And it can take a minute to just sort of stand back and look at it and let your eyes kind of adjust to seeing the patterns and the shadows in the tree.
Okay, I think I'll need to practice on that one then.
Yeah.
But as you mentioned, the furrows in a tree bark can actually be quite unique, right? So while I'm looking here, this is quite, it's smooth on these ridges here. It's quite rough inside the ridges. But I'd like to come back around on another little jaunt here and back to the tree that we started with, because I think this one has quite a unique bark as well. And that, of course, is our London plane tree. So Joy, you and I were talking a little bit about earlier on the call, why the plane tree has this sort of mottled look. Can you remind us why we see this color variation here?
Well, the bark on the plane tree is exfoliating. And what that means is that the outer bark peels off. Although I would encourage you, if you see some that's peeling off, don't rip it, just let it fall off on its own naturally. But it's growing so fast that it's sort of outgrowing its bark, and it's shedding kind of, sometimes you'll see them in like rolls, and sometimes you'll see little pieces, especially after a windstorm or a rainstorm, bits of that come off, and you're seeing what's underneath the outer bark.
Okay, so we're just seeing younger bark then. Those lighter sort of cream colors are just younger bark that's hiding beneath. Yes. That is quite a beautiful feature here. And right next to it, then I've got a Norway maple and a young Norway maple. And I say young there because actually the maple bark does change over time, doesn't it? And actually, in general, with trees, younger and older species can have drastically different bark patterns.
Yes. A lot of times trees that exfoliate, meaning shed their skin or their bark, like the plane tree, don't start to do that until they become fairly mature. But one thing you'll see is that saplings, small trees, are usually much smoother, and they don't have that sort of hard looking bark. Not that I would encourage you to do this, but if you break one, you can actually easily sort of tear it. It doesn't have a crunch to it. It has more of a ripping kind of feel. But yeah, they do change and harden and develop these interesting patterns over time that you'll see usually in older examples of a species. Carpine musselwood is one that's really interesting. That's a native hornbeam tree, Carpinus, and that when you first see it, it doesn't look like anything when it's really small. But as they grow larger, the bark becomes smooth and it looks almost like muscles in an arm. And that's a tree that often grows in areas that were previously cleared. We could talk more about that anytime. I could talk about that endlessly, but it's cool because it really looks like a mussel. So I think when learning to identify trees, one of the things that's helpful is to fix on it and say, what does it look like to me? And try to remember, okay, the tree's bark looks like something, whether it's ripples in a creek or mussels or jimmies on an ice cream cone, whatever it is that will help you sort of visually associate the bark with that tree as you're trying to remember what it looks like.
I love that. And I'm going to turn us once more back to, there we have our plane tree. For me, this looks to me like army fatigues, sort of an army outfit, like military uniform. And I love what you just said there about finding, once you've had that correct identification, finding the words that resonate most with you. And I think that's something that's really important in scientific observation. There are objective truths about the feature of this tree. There's also sort of those mental tricks that personally I can rely upon to remember whatever it is the heck I'm looking at. And those have come in really, really handy, certainly when I've been out doing field work, describing all kinds of mineral and rock features. Joy,
there's another thing you can do also to help you remember, and that is you
yes.
can hug the tree. Okay, so you can't hug people right now. You think I'm joking, but they have a feel, and when you put your arms around a tree, it's a feel that you'll remember. You can put your face against the bark, and you can remember that feeling of what it looks like to help you remember what tree you're looking at and identify.
I love that. I love that. Combining our sensory experiences with scientific observation. I love it. Keeping those lessons sticky. That's what it's all about. While you were chatting there, Joy, earlier, you mentioned that some trees infill areas that have been previously cleared. And it reminds me, thinking about forest succession, which I know a little bit about, but I'm really interested to hear from you on when an area is clear cut, some trees come back in, but some take a while to come back, don't they?
Yes. So, I mean, that's the first thing I notice when I go into a new area and I start looking around at the trees is what kind of environment is this? And what do the trees tell me about this environment? And so a lot of times you'll see, especially in urban and suburban areas, there may be forest areas that have grown up, but they actually once were cleared for farmland within maybe 100 or 200 years ago. And so the trees that grow back are different than the trees that were there before. And that has to do with a change in the environment that we've made by changing the light conditions, changing what nutrients and water are being taken up by the trees there and what's available to new trees to grow. And also sometimes, you know, just what species are the most aggressive about establishing themselves in areas the fastest. So maybe they have the most seeds, or they have the tastiest berries that squirrels and birds like to eat, and then they will plant the trees for
Help
you.
Disperse.
Sometimes trees like maple trees have lots of maples, including the Norway maple, are very aggressive about seeding themselves. And you'll see little seedlings all over, you know, or the floor of the forest or in your yard. They have samaras, these helicopter seeds that are actually borne by the air. They look like kind of like a mustache. Yeah, there.
In fact, they're all around the forest floor around me here. Of course, I'm standing next to that Norway maple.
So if you spin it, you may find that it flies a little in the air, and that helps it travel a little bit farther away from the mother tree and plant itself. So when you see, you know, strongly established, large, tall, broad canopy trees, and by that I mean trees that provide a lot of shade and provide a lot of habitat for animals and birds, they tend to shade out understory trees that are smaller, and they use the nutrients and resources, and those trees do not grow in those kind of forests very prolifically. But once the area is cleared, you know, it's survival of the fittest.
Yeah. It's a great point. So of course, what you're hitting on there is the potential impact of humans. In Pennsylvania, we can see the history of early settlement here quite well, not just within our tree species, but also within our soil. And this is pretty extraordinary in most areas that were previously farmland but are no longer. If we dig a soil pit, big hole down into the ground, you'll notice that the top 10 or 12 inches sort of have a different coloration, a more consistent coloration than the layers below it. And it's actually from previous plowing there. And I raise that because, as Joy mentioned, trees are intimately dependent upon, of course, the environmental conditions that surround them, and soil conditions can be a really, really strong control on which trees grow where, and vice versa. Some tree roots, for example, can release really, really acidic exudates. So this is the case around pines, for example. You see really acidic soil around pines. And then we see other smaller hedges growing in the area that can tolerate that acidic soil. We see this throughout the New Jersey pine barrens not far from you, Joy. There's quite sandy, well-drained soil. It's quite acidic as well. So of course, when we're talking, yes, go ahead.
Trees like the black walnut will actually kill off the competition. They secrete substances into the soil that makes it inhospitable for other trees to grow. But I will add, poison ivy has no problem growing on a black walnut.
Yes. Yes, and I am one of those that's always acutely aware of where the poison ivy is around me. So I get that stuff just by looking at it. Okay, so obviously we could yammer on all day about the magical prowess of different tree species, but I do also want to highlight that in addition to those environmental conditions we already mentioned, we know that trees can be intimately impacted by their local climate. And this is something that I've thought a little bit about. And Joy, you mentioned we consider when we're planting trees in and around the city area.
Right, so many times we'll choose a very hardy tree that can grow in really difficult conditions to use in urban environments because they're not going to get a lot of water, they may not have a huge amount of soil, and they may have to go really far down with their taproot to tap into the groundwater. And the downside of using trees that are really sort of hardy like that is that they tend to be also kind of aggressively spreading, and they tend to, if it's a place that's kind of barren or deserted or has had like a toxic chemical spill or something, many things aren't going to grow there because they won't be able to compete. So tree of heaven, ailanthus, is one of the trees that often grows in disturbed, sometimes polluted soil, and that is one of the key hosts of your spotted lanternflies.
Yes. Yes, absolutely. A very problematic species in this area. Now we know that we don't want to plant them, but it used to be the fad to introduce those trees because they established themselves quite quickly. And because, as Joy mentioned, they could really tolerate not such great soil and air pollution conditions. So they did quite well in city areas. Of course, I'm very interested in the positive impact of urban street trees because they can have a cleaning effect on the air around them. We often say that trees are the lungs of the planet, right? We know that they take in carbon dioxide, and through photosynthesis, eventually they release oxygen. Of course, we like oxygen, so that's all well and good. But some folks also refer to trees as the liver of the planet, and it's because they can quite literally filter out pollutants from the air. They do this quite well with sulfur dioxide and nitrous dioxide as well. And of course, these are pollutants from burning fossil fuels. They can come from factories and also from our tailpipes.
I have a question about that.
Yes, please.
So if I know that most trees, when they die, you know, they decompose, but sometimes trees are petrified or they become fossilized. Can you tell anything about the climate of the past from those remnants?
Sure. Yes, it's an excellent question, Joy. And often what we can tell most is by those fossil imprints. So it's actually quite challenging to find fossilized wood, but finding imprints of leaf structure, for example, is not too hard. You know that I've done some research in Antarctica. I was really fortunate to be a part of a research project that was studying a deposit on a feature called the Fries Hills, and this is in the dry valleys region of Antarctica. It's very cold now, of course, but way back when, perhaps 15 to 17 million years ago, we were looking at much more moderate conditions there, maybe on the order of 20-30 degrees Fahrenheit. And we know about that temperature range because of the discovery of a fossil leaf imprint. So I was responsible to help understand the age of the rocks and the sediments that we were looking at, but we collaborated with other scientists that are called Paleo botanists. So they study botany of the past. So these are fossil deposits that they study. And what we could tell from the leaf morphology, it was so well preserved that we could make out its edges. We could tell something about its stalk, and we could also see its venation, which is actually quite rare in a fossil species. And through that, we could tell that this was a part of the Nothofagus group. Now, this is a very common tree. It's a southern beech tree, still found throughout the world, but primarily in those mid-latitude regions. Today, for example, we might find the climatic conditions that an Orthophagus would grow in is perhaps the Georgian Islands, let's say, where we might expect to see these trees. So when we find them on terrestrial deposits in areas that are today quite cold, obviously it tells us something about a warmer climate in the past. And that whole process is called paleoclimatic reconstruction, which is a big long term for basically helping us understand climates of the past. So we have a lot of tools to help us understand how climates have changed over not just the last few thousands of years, like more recently buried tree species and tree rings, but also heading back into the millions of years. So it's a pretty extraordinary tool we have at our disposal. So I'm glad that you brought that up there, Joy.
That's so cool. I mean, I think about paleontology and I think about dinosaurs, but the dinosaurs had to eat something, right? There were trees and forests that they lived in.
Yeah, of course. And fossilization is such a random process. It's quite low probability that any one species will be fossilized. So to be able to find all of those different variables that tell us about the whole ecosystem is quite special. But fast forward to today, of course, I'm also thinking about living tree species and how they can have, as I mentioned, that positive impact on our air pollution in the city. And I mentioned
happening in Philly.
Right. So we know that here in Philly, we have all kinds of efforts to plant trees. If you're interested, check out the Pennsylvania Horticultural Society Tree Philly program. You can actually get a free tree from the city. They'll support it, and they'll the PHS, the Horticultural Society, also supports a program called Tree Tenders, which will teach you how to care for the tree and maintain it. And also, we pick those species that, as Joy mentioned, grow best in not ideal soil conditions, but also those tree species that have root systems that don't disrupt sidewalks or disrupt water pipes. This is a common concern in the city, but turns out that the Horticultural Society has found those species that do quite well delicately with that underground infrastructure. So we do have that know-how these days. And beyond providing that cooling effect from the shade and beyond providing that beautiful feature on our sidewalk, of course, they also help filter out those air pollutants that I mentioned, and they sequester or they take carbon out of the atmosphere. It's pretty amazing to think about this tree and all of its woody mass essentially has materialized from thin air, quite literally. The vast majority of, if I could take this tree out and measure every gram of it, get the mass of every gram of it, it was ultimately the carbon within it came from CO2 in the atmosphere. So yes, the roots do take up some little bit of nutrients and water from our soil, but the vast majority of the mass of a tree is just coming from thin air, which is just pretty extraordinary, I think. So along that line, then, of course, yes, we pull carbon dioxide out of the atmosphere. And I believe, back of the envelope calculation, that the number of trees that we have in the city of Philadelphia today completely offsets roughly 300,000 individual American households worth of carbon emissions. So I'll repeat that because I think it's a really extraordinary statistic that the trees in Philadelphia do counteract just about 300,000 households worth, American households worth of carbon emissions. So yes, of course, trees can have a very, very positive impact on current air pollution conditions and also overall carbon in the atmosphere. Of course, we want to pull that out to help cool temperatures overall. So there I am on my climate soapbox again, Joy. But I think I'll pause us there. And we've yammered on, and I hope to have you back again to say more. Oh, we have one last question before we sign off. Go ahead.
What are your and Joy's favorite ornamental?
Oh, what a lovely question to end on. Joy, we were asked what our favorite ornamental trees are. And I will say that we've been talking about maples. Well, the Japanese maple is my favorite. I'm currently trying to rear one on my back deck, but I don't know if it's going so smoothly. But Joy, of course, you've had great experience designing with trees. What's your favorite ornamental tree?
Oh, it's hard to say because there's so many beautiful trees that have different purposes and grow in different conditions. But I grew up in apple country in Washington State, and so I love an apple tree. And while you may not be able to have an apple orchard in your backyard, there are crab apples that are beautiful, and they have an amazing flower in the spring. They provide food for birds with their little tiny sour apples, and they're all different species. I just think they're beautiful.
Beautiful. I love it. So Joy said an apple tree there, and I said a Japanese maple. I love that we're ending on those favorites. So we've had a wonderful discussion here, and as I said, I'll wrap us up. But I did want to point out, of course, I'm wearing my NASA meatball today, and Joy, I think we talked a little bit about this. Why am I wearing my NASA shirt today?
Something very big may be happening, and now I haven't been able to keep up with what's going on while we've been talking with the weather, but there might be a really big launch today, right?
Yes, absolutely. Of course, we're going to see I believe it's the first rocket sent up containing NASA. What am I trying to say here? NASA astronauts. There we go. Getting stuck on my word. NASA astronauts. It was a partnership between NASA and, of course, SpaceX. So this is unique because of that commercial and that public agency pairing, which it sounds like might be the sort of future of space travel.
And it's the first time Americans will have launched to the ISS from American soil in over, I think, around 10 years. We've been hitching a ride from with shuttles that come launch out of Kazakhstan. Yep. So this is Cape Canaveral, where, you know, as many of us grew up watching launches on TV of the space shuttle. So it's the first time for that, and it's the first time actual people are going to go to ISS in a commercial government partnership situation. That's the SpaceX organization. So fingers crossed that will happen today.
Yes, and it sounds like it's the first shot off from American soil since 2011. So yes, Joy mentioned it's been quite a long time. So we are certainly the TFI team is all anxiously awaiting this. So we'll keep our fingers crossed. Hopefully it's good weather down in Cape Canaveral following this. Right now, the launch time, I believe, is set for 4:30. So you've got a little bit of time here to run to the bathroom and grab a snack and come back to your computers to watch that launch. And we hope to be watching alongside with you. So I think that does it for me. And looking around at Earth's surface today, tonight I'll be looking up a little bit. Joy, thank you again for joining us. And I hope we can have you back again. Thanks to everyone out there watching, and we'll see you next time on Franklin Outside. So Katie usually lets us know when the face